So I do 1 plus 2 plus 3 plus 4 plus 5 plus 6.
No. For positive integers. Okay. I believe you would have to do. Oh, okay. So what would you get when you do that? 1 plus 2 plus 3 plus 5 plus 6?
21.
Okay. And any idea what you do next?
So when it says plus n,
N is 6.
oh, right. So am I then doing subbing in 6 times 6 plus 1 over 2?
Yeah.
And then that would be...
And what should you get?
Yeah, I've got 21.
Yeah. Any idea what else you do?
I'm not sure.
You do 1. So 1 is identical to, and then you sub 1 in for n. And then you do 1 plus 2. Then you do 1 plus 3. And so on.
Oh, so I do it for all the numbers.
Yeah. You exhaust all possibilities.
So for the second one, I do 2 times 2 plus 1 over 2.
Yeah.
And I got 3. For the next one, I do 3 times 3 plus 1 over 2. I got 6.
Okay, for 4?
4, I do sub 4, and I got 10.
You have to show. How do you show you're working out though? What would be the full thing?
So I do 1 plus 2 plus 3 plus 4 is the same as 4 times 4 plus 1 over 2.
Yes, and then you say that that's equal to what was it, 10?
Yeah, 10.
And yep.
For 5, I do 1 plus 2 plus 3 plus 4 plus 5 time is the same as 5 times 5 plus 1 over 2. And that's 15, sorry.
That's 15. And then we did the 1 to 6, and we got 21. I think this is the triangular numbers. I think that's it. Let's just see, because there doesn't seem to be a statement to say therefore at the end or something. Is this it? 13b. Makes an attempt to substitute any. Yeah, sure. Successfully substitutes into that. Okay, draws the conclusion that as the statement is true for all numbers, it has. Okay, so we have to just say something like.
Therefore, it's been proven by exhaustion.
Yeah, something like that.
Okay.
Okay. Any questions about that?
No.
Let's just see. And so, did you want question 2? Just go through this paper, or?
Yeah, we can probably just continue, I think.
Okay. Next one.
I'm going to put this on places. Okay, so I think if I find Is that called the double angle formula, the one on the left?
Yeah.
Yeah, because if I know what the double angle formula is for that, which I forgot what it is now.
So it's given to you on the formula sheet. It'll
Yeah.
say sine A plus B, sine A cos B plus cos A sine B.
And it will be 6 times both of those sides, won't it?
Yep.
It will be 6 times sine theta cos 60 plus cos theta sine 60. And then make that equals to 8 root 3 cos theta. Should I expand the brackets for that?
Yep.
And actually, so if I do 6, so if I do 6 sine theta cos 60, it's not giving me an answer for cos 60.
It's because you're in radians.
Oh yeah. So yeah, so I got 3 sine theta plus plus 3 root 3 cos theta equals to 8 root 3 cos theta.
Mm-hmm.
And then if I minus that, it'll become 0. What I then do, will that be like 2, 3. And so I'll get 3 sine theta minus 5 root 3 cos theta.
Okay.
And then should I divide by both sides by cos?
Mm-hmm.
And then that'll give me 3 tan theta minus 5 root 3 equals to 0. I'll actually just do equals to 5 root 3. And then it'll be tan theta over 5. So tan theta is equals to 5 root 3.
Mm-hmm.
And arctan of 5 root 3 over 3 is equals to theta.
That's it.
And then try to put that to my calculator.
Yeah.
For some reason, for some reason just like sort of forgot how to do solven in my graphical.
It's because you're doing too fancy. You I have some page that's full or something. Do I? For some reason, this looks like a calculator. Let's get rid of that. Just do arctan 5 root 3 over 3. So shift tan and then 5 root 3 over 3. Root shift.
So it says it only wants from 0 to 360.
Yeah.
And did it say like to what decimal place and stuff like that?
1 decimal place.
So I got 70.9, 250.9, and 430.9. Oh, that's too high. Sorry. No, so I got my two answers are 250.9 and 70.9.
Where does the 250.9 come from?
My calculator.
Tan repeats every 180, and so the way you'd show you're working out for that would be theta equals the 70.91 plus another 180.
Oh yeah.
Repeats every 180. Yeah, and you can get the answers in your calculator. And keeping in mind, if you wanted to check everything, option calculate solve n 6 sine bracket theta plus 60 close bracket twice equals 8 root 3 cos theta close every bracket, is it? Syntax error. Don't close the bracket. Oh well, you got the answers. You know what you're doing. Oh, there we go. That worked, I think. Oh, maybe it didn't. I don't know. 6 sine x plus I see it. I'll try to quickly. That shouldn't be there. That's why. Sorry about this. There we go. So just gives us lots of solutions. There we go. 70.9 and 250.9. But you have to show you're working out. Great. Any questions about that?
No.
Okay. Okay, question 3.
Okay. So I'm guessing it was something to do with like it's the starting room temperature or something like that. I'm not sure.
No. Initial temperature. Anything you know about initial?
Did it start at 0?
Yep. What's 0?
The coffee.
I don't know what that means.
So is that small t?
Yes, time. Time is 0.
Yeah.
And so sub in t equals 0, the t of 0.
And so that'll be... am I just subbing in like t0 equals to tr plus 90 minus tr to the e of minus 1 over 20 times 0?
Yeah. What do you get?
So I got 0 is equals to tr plus 1, I think. Oh no, it'll be 0 plus tr plus 90 minus tr.
It'll be, say it again, sorry?
So it'll be just plus and then brackets 90 minus tr.
Yeah, or even without brackets, because it's just times 1. And so, yeah, there's no, basically anything to the power of 0 is 1. Yeah, so the initial temperature of the coffee is independent of time because time has been eliminated or something. Okay, question B.
So that just means I need to sub in 10 times 20 is equals to...
No, not 10 times 20. The t of t. It's like the f of t.
Oh, so does that mean sub in 10? Oh no, the temperature of the coffee after 10 minutes, the room temperature is 20. So does that just mean sub in 20? Is that like the t of 20?
It's t of 20, yeah.
Or would it be...
No,
right.
Sorry. Room temperature.
Yeah.
Room temperature is 20.
So would it be the t of 10?
Yeah.
And so is that going to be tr...
What is tr?
20.
Yeah.
Plus 90 minus 20 times e to the power of minus 1 over 20 times 10. And I got like a decimal, but I got 62.5 degrees.
That is 62.5 degrees Celsius, and an exact value that would be e to the minus a half. Okay, but obviously that's not very helpful. An exact value in this case, you'd want something like 62.5 degrees. I'd just like to see exactly how they phrased part A. Second part. Concludes that the TR terms will always cancel. Oh, could we have simplified? That's what we needed to do. Sorry, simplify part A.
And so, oh yeah, that'll just be 90.
Yes. And so because there is no room temperature thing, because room temperature has been eliminated, the initial temperature of coffee is independent of room temperature. Because TR was eliminated. Yeah, we just needed to fully simplify. Okay. Part B, sub in 20 and 10, 62.5 degrees. Any questions there?
No.
It's all right. Okay, question 4.
So, okay, so 10 minus 2x to the 4. So I need to do I need to first of all integrate. Oh my days. So I need to integrate 10 minus 2x to the power of 4, don't I?
Yep.
And so that'll be 4 brackets of 10 minus 2x.
Okay.
And then the first 2 brackets times together will be...
Andrey, you cheek this man today. So many things. So if you wanted to quickly expand the brackets, you could use binomial expansion. You can also integrate by reverse chain rule.
Sorry?
How would you differentiate this?
Would that just be 4 times and then bracket 10 minus 2x and then to the power of a cubed?
Yes, and don't forget the times by derivative of function inside function.
So is that just 4 times 10, 4 times minus 2x?
What is the derivative of 10 minus 2x?
That would be minus 2.
And so it'll be minus 2 times 4 bracket 10 minus 2x power of 3. So now, if you were to work in reverse, add 1. So try integrating this. How do you do it?
I would do should I just expand the brackets, or I can't do that?
You cheat this man. Add 1 to the power.
Oh, of course, yeah. So that'll be to the power of a 4, and then divide the left side by 4.
Yep. So I'll divide by the new power. That would give us, we'd have an extra minus 2 on the outside. What do you have to do to get rid of that? How do we get rid of times minus 2?
I don't know.
Divide by minus 2.
Okay.
Of function inside function. I'll just call it like that. So you differentiated it by doing multiply by the power, subtract 1 from the power, multiply by the derivative of function inside function. You do the reverse to integrate it. Add 1 to the power, divide by the new power, and you divide by the derivative of the function inside function.
Okay.
So I'll try that.
So am I now? So I now need to divide that by minus 2. Yeah.
Yeah. So that's just practice. Okay. This one over here. Integrate.
So that'll be to the power of a 5.
Yep.
And then divide the left side by 5.
Yeah, so I'll just say times a fifth or something.
Yeah. And so yeah, 5th. And then 10 minus 2x to the power of a 5, I think.
Yeah.
And then do I need to differentiate that here? Or?
And then you divide by the dy dx of function inside function.
Oh, so now I need to divide by -2.
Yeah. And I'll write that as times -1/2.
Okay.
What's next?
Do I then put 4? Do I now sub in 4 into each? Do I then just sub in 4 into the x value?
Yeah.
And then minus. So when I sub in 4 and then minus the same equation by subbing in a,
Yeah.
and make equals to 211 over 10.
Yep. What is a fifth times -1/2?
-10.
So that might make it just a little bit less for the calculator. So -1/10. 10 minus 2 times 4. Power of 5. And then you sub in a.
And then do I make that equals to 211 over 10?
Yep.
And then do I now need to expand it? And so not expand it, but like just get the answer, and then they'll. So for the first one, I got so for the first one, I got -16 over 5.
Yep.
And for the next one, I just need to sub in x here. So that means that it will become 10. So it will be -1/10 times 10 minus 2a.
Yeah.
And then should I add 16 over 5 to both sides?
You could.
And then that'll be 243 over 10.
Okay.
And then divide that by -1, which will be -243 over 10. And then I think that here I can just put into my calculator, can't I?
Yep.
And so that'll be I got -116.5.
Let's see. Ooh, calculator's having a hard time. Something seems wrong with that. Did I put it in right? Oh, I didn't. Alpha equals 211 over 10. What was your number?
Minus 116.5.
I'm getting 3.5.
I just put in minus a tenth times 10 minus 2x is equals to minus 243 over 10.
Do you have it in brackets and stuff?
Yeah.
No. Something's very wrong. I bet if I put that in, I'll get... So, minus 1 over 10. So you've shown you're working out. You've done everything you're supposed to do. 10 minus 2x equals minus 2, 4, 3. Shift solve. No, you're right. Let's think about this. So it's basically that 243 over 2 minus 243 over 2. Something went wrong somewhere. Let's see, it's probably just some little thing. Yeah. So we integrate this, we get 1 over 5 times minus 1 over 2. 10 minus 2x to the power of 5. That's between, and we have to the power of, oh, we forgot to the power of 5, sorry.
Oh, right, yeah.
It's power of 5. Change it to be to the power of 5.
Yeah.
Sorry, I forgot to write.
Yeah, I got 3.5.
Great. Yeah, that's fully right. You showed you working out. Every part is that. Every part of that's good. And just for the sake of whatever, mark scheme. So 7 over 2, 3.5. Let me see. States this, makes an attempt to solve this equation. 243 is seen. Yeah. Okay. And if you're ever stuck, you can always just manually solve it, like times both sides by 10, all that. Any questions there?
No.
Okay, question 5. We did one like this before. You were pretty good at it. Is it worth doing?
Probably, yeah. So do I need to make the assumption that there are positive integer solutions to the statement?
Mm-hmm.
And then do I then need to say something like I don't know, like x is equals to minus n and y is equals to minus m or something, or
you're trying to prove positive. Use proof to show that there are no positive integer solutions to this statement. Positive integer solutions. Do you mean for x and y? So if you're trying to show positive, then you wouldn't show negative, you'd show positive numbers.
So I need to do I need to then say I want to put x squared equals to m or y squared equals to n or something?
It doesn't really help, like changing the name of x. Anything else you can see?
Factorizing x squared minus y squared or something.
Uh-huh.
And so will that be x plus y times x minus y?
Mm-hmm.
And then do I need to then set -1 and make it equal to 0 or something?
I'm not sure myself, but then you'd have to make it in the form of... Do we have to refactorize? Oops, -1 equals 0. X squared minus 1 minus y squared. Proof by contradiction. I'm not sure how you represent all possible positive numbers. There exists positive integers, yeah. Then they factorized it. Okay, let's think about this logically. If they're both positive, the trick I think is integer. Maybe not. States there's only one way to multiply to make 1. Okay. So 1 times 1 equals 1. So 1 times 1 equals 1. So what will be next?
Oh, so can we then say something like x plus y is equals to 1?
Mm-hmm.
And x minus y is equals to, or equals x minus y is equals to 1.
Mm-hmm.
And do we then need to square both sides?
No. Maybe, but x is like 1 minus y, or x is 1 plus y.
Yep.
My guess is if x is greater than y, then one of these will be negative, or if y is less than x, one will be negative. This creates a contradiction because it can't, at least one is negative, therefore there are no positive.
Yep.
Let's us see. X minus y equals 1, x plus 1. Solve this pair of simultaneous equations. Oh, all right. Solve the pair of simultaneous equations. X plus y equals 1, x minus y equals 1.
So am I doing, do I need to do x equals to 1 minus y and then sub it into the other equation?
Yeah.
Or, okay, so will that be
Calculator.
1 minus y equals to 1.
Yeah.
And so that will be 1 is equals to 1.
Yeah. So just put it in the calculator.
Oh, yeah.
X is 1, y is 0.
And therefore, do we say that as there's an integer solution, we've proven this by contradiction or something?
0. What do you know about 0?
It's equals to y. I don't know.
0 is not positive.
Yeah.
And that's the contradiction.
Alright, okay.
Contradiction. Therefore, no positive integer solutions. Let's see. Okay, so this is good. Factorize is good. So, they're really scraping the barrel with these proof ones. 1 is the same as 1 times 1. Like something times something gives you 1. The only possibility is 1 and 1. And so either x plus y is 1 or x minus y is 1. Those two are so simple that I didn't notice that they were simultaneous equations. Solve them and you get a contradiction that one of the answers is 0.
Okay.
That's not positive. All right. Any questions there?
No.
Okay. I'm trying to see. Makes a valid conclusion. Yeah. Okay. This one. Question 6.
I think I could do this one. Should we move on to question 7?
Yeah.
Okay.
How do you... What is 7?
I think I can probably do this one as well. Should we move on to question 8?
Yeah.
Okay. So... What does concave mean again?
It is to do with differentiation. So you'd have to differentiate it. There we go. F double dash of x is less than or equal to 0.
Okay. So does that mean I need to do like x cubed plus 6x squared minus 12x plus 6 is smaller or equals to 0?
The double derivative of that is smaller or equal to 0.
I need to differentiate twice.
Yeah.
So will that be 3x squared plus 12x minus 12?
Mm-hmm.
And then I need to differentiate that.
Mm-hmm.
And that will be 6x plus 12.
Mm-hmm.
And so when it says, do I need to sub in minus 5 and minus 3 or something?
Let's see.
Oh, should I solve for x first?
So solve for x. What do you get?
Minus a half.
Okay. I mean, I think you've kind of just done it there. X is less than or equal to minus a half. The interval like between minus 5 and minus 3 is also less than or equal to minus a half. Like minus 5, minus 4, minus 3, you know, minus 3.1. They're all less than minus a half. I'll just call it minus 0.5. Therefore concave. Part B.
So do I need to get the x coordinates first?
Yeah.
And so x is equals to it's decimal numbers.
What are you solving?
No, I just put in y equals into my polynomial calculator.
That'll give you the roots, I believe.
Yeah.
That won't help.
So the point of inflection is so is the point of inflection usually like near y equals to 0?
No.
I'm not sure.
It is when dy dx equals 0 for stationary points in general. A point of inflection is a special one. I believe the double derivative is equal to 0.
Oh, so that'll just be so x is equals to minus a half.
Yep. Coordinates.
Would it be to get the y coordinate? Do I sub in minus a half into y equals?
Yep.
I've got 107 over 8.
8 minus a half, 107 over 8. Let me see. So if I just go to my graph, you see the maximum up the top?
Yeah.
Local maximum. There dy dx is equal to 0. Down the bottom, dy dx is equal to 0. I'm actually not seeing a point of inflection, but it's just because it's so zoomed in. It's when it goes from dy dx is also equal to 0, so the gradient is also 0, but it doesn't change direction. It just goes for a second and then it continues on. So it goes positive gradient, 0, positive gradient, negative, 0 gradient, negative. Let me make sure, because we might have to. Did I want to show it? That one we did skip. X equals minus 2. Oh, it's because minus 12 divided by 6 isn't minus a half. It's minus 2.
Oh, yeah.
Yep. And so minus 3, minus 4, minus 5, they're all less than or equal to minus 2. And so you just sub in minus 2 instead.
Yep.
And you get whatever. What if they had said convex?
I don't know, triple differentiation, I'm not sure.
Convex. D squared y by dx squared is greater than 0.
Okay, yeah.
Yeah, so you have to get double derivative, make it greater than 0. And what was this one? Plus 24 plus 6, that's minus 2, is it 46? 46, yeah. So concave, double derivative less than or equal to 0. Any questions there?
No.
Okay. Question 9. How about this one?
So the formula is a plus n minus 1 d. And if I do a plus 3d equals to 98.
Mm-hmm.
and A plus 10D equals to 56. Well, A is 116 and D is -6.
Okay.
And so do I then need to do 116 plus 20 -1 times -6, and then 2.
2, is it?
Yeah.
Question B.
So does that mean like 116 plus n-1 times -6 equals to 78?
No, it's not. A term is 78. The sum.
Oh, is that an arithmetic series? And that was like n/2 times 2a plus n-1d.
Yeah.
So am I here doing n equals to 78? And so am I here going to do n/2 2 times 116 plus n-1 times -6 equals to 78. And then I don't know if I put in wrong, but I got a pretty bad answer.
You should get 2 answers. I believe it would be quadratic. Okay, let's do it manually.
I don't know, I did it wrong. So
did you close the bracket after that times -6 or something?
I forgot to put -6 in. So I got 2/3.
That can't be right.
Okay.
Has to be a whole number. How'd you do it manually?
I would do what do I first of all do? 2 times 116.
There's a second solution. That's why it's 39. Did you put it into the graphical one?
No, I put it into my scientific.
Okay.
Yeah.
You could times both sides by 2 to get rid of the fraction.
Yeah. And so that'll be and then n times 232 minus 6n plus 6. And then equals to 156, yeah. And then if I expand out the brackets, I'll get -6n squared plus 232n, or even just 230 plus 238n minus.
There's no n. That wasn't times by n.
Pardon?
I don't think that was times by n, was it? Oh, yeah, it was. Sorry. Yep.
Okay. And then, am I doing just minus 156?
Yeah.
And then my solutions are. Yeah, 39 and 2/3.
Yeah. And it has to be, an integer because it's n. Let's see. Let us see. So that's why your graphical calculator comes up with that thing saying additional solutions may exist. Although it does pretty good at getting you the many of the solutions. Mostly it gets all of them. Simpler one just gets you the first one. I subbed in as my guess number 999, and after that I was going to try minus 999. Let us see. Good for the first half, simultaneous equations, that's all right. And then second half, so just read it carefully. It's not the nth term, it's the sum of the first n terms, and so it's the sum arithmetic series formula.
Yeah.
Sub in a, sub in n, and solve. Any questions there?
No.
Cool. Let's just see. So how do you prove by exhaustion?
Just literally use all the numbers they're given, basically.
Yeah.
Exhaust. Yeah.
Yeah. What you call it? Exhaust all possibilities. This one, how do you do these?
Just use the formula given in the exam, and then just divide when you see sine and cos, just divide by cos theta, and then merge my graphical, and then
and arctan 5√3/3. Tan repeats every 180, so you add tan to previous answers. These ones. What do you know about initial time?
Is it just it's like.
What do you know about time at the initial starting point?
Oh, it's 0.
Yeah, and that's very common, that you'd have to sub in 0 when they say initial. Other than that one was okay. This one, so this is a weakness. To differentiate, power times coefficient, subtract 1 from the power, and then don't forget to multiply by the function inside the derivative of the function inside the function. And so to integrate, it's the opposite. Add 1 to the power, divide by the new power, and then divide by the derivative of function inside the function. We missed out on the to the power of 5. I just forgot to write it down, but other than that, that was all correct. Any questions about this integrating one?
No.
Okay, let's see. Proof by contradiction. There's so many of these that it's kind of difficult to come up with any kind of formula for it. Difference of two squares, make them, factorize them, and okay, one has only itself as a factor, 1 times 1, and then solve the simultaneous equations. But there's really no way to extrapolate that out, I don't think. This one, what do you know about concave function?
It's going to be differentiated in smaller than 0.
What derivative?
Double derivative.
Yeah. Convex?
Double derivative then greater than 0.
What do you know about stationary points?
Isn't it like differentiated then equals to 0?
Yeah. What do you know about point of inflection?
Was it Oh, I forgot that one.
So you kind of got it yourself. Point of inflection, d squared y by dx squared double derivative is equal to 0. So concave, double derivative less than or equal to 0. Convex, double derivative greater than 0. Point of inflection, double derivative equals 0. And then this stuff, you're pretty great at this. Yeah. How was that for you, Andrey?
Yeah, that was good. Thank you.
Well, good luck in your test anyway.
Thank you.
Hopefully it all goes well. Any questions for me in general?
No.
Well done, Andrey. You did great. And I'll see you in 2 weeks, is it? Not next week, but the following one?
Yeah.
All right. I'm crossing my fingers for you in this exam.
Thank you. Cheers. Thank you.
All right. Goodbye.
Yeah.